Hello to everyone. So today we are doing this graph. We're answering questions on this graph. We're going to analyze it. Let's start. The graph is of the energy of photon. So that is the energy of photon, the square of the distance of the maximum speed. No, square of the maximum speed of photoelectron. So let's look at the graph. On the y-axis, this side are the y-axis, these are the y-axis. So on the y-axis we have the energy of photon. This is the energy of photon, that is our y. Then on the x-axis we have the squared speed, so that is our x-axis. So this is our x-axis. Okay, then we have this area. This area is the y-intercept. So this is the y-intercept, this one. So x there is 0, y it's 7,48 times 10 to the power negative 19. So we have these coordinates here. This is the y-intercept. And remember that your x is your v squared. So your x is v squared. Then your y is your energy. Your y is E. So we have as coordinates, which is v squared versus E. That is 0 v squared. Then E way to now. Okay, then we have x here. X is speed at this point, x is speed at that point, which means the coordinate there, the coordinates, it's x, which is a speed, versus 11,98 times 10 to the power negative 19. Okay, now let's go to the questions with this information. Let's go straight to the questions. The first question, they say use the graph to write down the value of the work function of silver. So I will use the graph to get the value of the work function. Knowing that the work function, we get it kule formula. This is EK max. This is EK max. This is the work function. This is what we're looking for. E is the energy of photon. That is Y. This is our Y part. Then EK max. Asinayo we graph EK max, but we know that the EK max is the same as 1/2 mv square maximum. That is EK max. So we have that EK max simchange abe mv, because a graphing sinikwe the mv square maximum. Okay, so we can substitute. We can take any point. You can take any point. You can take this one. You can take any point. You can take this point. You can take any point here. But the one that is simple is the y-intercept, this one, to get the work function. Here the speed here is 0. The speed here is 0. Since the speed is 0, therefore the kinetic energy is 0. Then the energy E is 7,48 times 10 to the power negative 19, which is equal to work function plus this 0, because of S speed yonke 0. Therefore the work function is equal to 7,48 times 10 to the power negative 19 joules. This is the work function. They said write down the work function. The work function nansi energy when electron ingahambi. when the electron has no kinetic energy, the energy that you get there is your work function. Y-intercept in this case will be the work function. So that is the work function. They said use the relevant equation to justify your answer. Sesiyisebenzisile equation part to justify the answer yethu. Sesiyisebenzisile already. Okay, now let's go to the following question. Let's go to the following question. Sesiyisebenzisile up. The kinetic energy EK is 0 because of the speed. Therefore, if the kinetic energy is 0, therefore energy E is equal to the work function. Because if you put 0 here, you will get the work function equal to the energy. So now let's go to the next question, fast and quick. Which physical quantity can be determined from the gradient of the graph? So, i-gradient ye-graph yethu ingasinika eyiphi physical quantity. Okay, now the easiest way is to write the main equation. E is equal to the work function plus EK max. So that's the first thing that you need to do. Now if we can look here, we have this line, this straight line. The equation of a straight line is equal to y is equal to mx plus c. This is the equation of a straight line, where m represents the gradient, c represents the y-intercept. If you still remember, we said the y-intercept is the work function, which means let's rearrange this formula so that ibe form it y is equal to mx plus c. Then we'll see what will happen. Now our y-axis is the energy, which means this is already y. Then this one is the y-intercept according to the equation. This is the y-intercept, so plus what? Work function. Then we have this one. Asinayo igraph yethu le masiyichange ibe ngu-1/2 mv squared. 1/2 mv squared. Okay, so ithethe ukuthi ke ngoku le nto, let me write this one. This is supposed to be E. This is our E, which is y in place of y. E is in place of y. Then the kinetic, or this one, is our y-intercept, because we said C is the y-intercept. Then this one, asinayo graph, let's change it. It's 1/2 mv squared. So it's now 1/2 mv squared max. Then if it's not wrong, we x-axis kukho mv squared max, which means this part is our x, because we x-axis. Sishiye ke ngonabani no m, ome endaweni kabani ka m. This is the mass in this formula. M endaweni ka m in this formula, m is gradient. That is the gradient. Meaning that a gradient, in this case, gradient represents the what? The mass. Gradient represent the mass. So a gradient siyayifumana ngokuba yi-mass ye-photoelectron gradient yethu. Or you can calculate it. You will see that it's a mass of photoelectron. How to calculate a gradient? You will say gradient is equal to change in y over the change in x. Then you choose 2 points, then you substitute. Now if you can look here, if I'm not mistaken, we have y with energy. So we have energy y power divided by x, we have uv squared. Now if you can look at the formula, E is equal to work function plus let's say we have 1 over 2 mv squared max. We want or in fact, let's leave it like that. This is the gradient, then you substitute by values, then you get the gradient. It will be the mass of a photoelectron. Let's leave it like that, hoping that sifumene here. Okay, now let's go to the last question. It must calculate your x. Let's calculate x. Even here we use the same formula. E is equal to work function plus 1 over 2 mv squared. Now if you can look at this one, x ume endaweni kabani ka mv squared. Okay, so let's go and check. Then if usingajonga apha, x unqwamana ne-energy engu-11,98 times 10. So let's substitute. Our energy is 11,98 times 10 to the power negative 19 is equal. The work function is already calculated there, up there, 7,48. The work function is 7,48 times 10 to the power negative 19 plus 1 over 2 m of electron times x, uv x per x squared. Okay, now let's go to the data and check the mass of one electron. Okay, the mass of electron, I will just substitute here. The mass of electron is 9,11 times 10 to the power negative, it's negative 31. Then let's divide both sides by 1 over 2 times 9,11 times 10 to the power negative 31. 1 over 2 times 10 to the power, oh not times 10, times 9,11 times 10 to the power negative 31. So we are left with x squared, which is equal to, let's press the calculator. Okay, so we press the calculator. We are left with x squared. Alright, then we get this one. We apply square root both sides, then x is equal to 944,34, then meters per square meter per square second. That is x. That is x, yes. Then we have x way 2, which is very simple like that. Okay. Thank you.